Hi Calculus, welcome back. Our objective today is going to be to find basic antiderivatives, and it's basically what it sounds like, just the opposite of a derivative. I've got the checklist on the screen, you know what to do. I also have added today, make sure you've got your kind of derivatives formula sheet out because that will be a handy reference for today. All right, I'm going to force a pause on your screen. I'd like for you to just write these two in your notes, please. And then we're going to talk about the differences. So if you think about, we've been looking at this type of integral thus far. So we're going to think about what that means to you, and then we're going to jot down the two differences. So aesthetically speaking, the only difference between these two are the values you have on top and bottom here, right? The limits of integration. So the one on the left is called, let's write this, a definite integral. And the one on the right is then called an indefinite integral. Okay, again, we can see that this one has an A and a B, and the one on the right does not. Okay, now the one on the left gives us what? This gives area, right? From x equals 0 to x equals 3 of the curve 2x. And your answer here is going to be a number, a real number, right? Because it gives area. Now the one on the right gives all antiderivatives. Little quotes there. All antiderivatives of the function f of x equals 2x. We're going to talk more in depth about what an antiderivative is. And so your answer here is not going to be a number. It's going to be what we call a family of functions, okay? So it's going to be several functions, but they will all be related, as we will see soon. Okay, so let me ask you this. Do you think you can think of an antiderivative for 2x? In other words, can you give me a function whose derivative is 2x? What do we think? Yeah, so one option is, oh goodness, x squared. Oftentimes we label the antiderivative with a capital F of x. So one option is x squared. Can you think of another option? How about x squared plus 5? Will that work? Yeah, x squared plus any constant would work, right? Because the derivative of a constant is 0, okay? So the answer to the integral, the indefinite integral from 2x dx is just x squared plus c. So again, we go in between the integral symbol and the dx. We say, okay, what is the antiderivative of 2x? So that's what these two symbols mean. It's kind of your capital letter and your period at the end of the sentence. So you need both symbols, and together they mean find all the antiderivatives of the function in between those two symbols. Right now, very, very odd that we're using such similar symbols for such what seemingly very different things, right? Like one is giving me area, one is giving me like an opposite of a derivative. Why are we using symbols that look so similar for such, again, seemingly different things? And we will find out soon. But right now, I just want you to get used to that notation as well and get used to finding some antiderivatives. I'm forced to pause on your screen. We're going to do kind of a pre-example here. Can you try to find me an antiderivative of 2x cubed? In other words, can you find me a function whose derivative is 2x cubed? Okay, so one option, I'm going to call it capital F of x here. One option would be, I know that my power needs to be 4. Now, did we figure out the coefficient? How about 1/2, right? And I could add any constant to this. I'll do capital C for constant. Now, how can I check it? I can check it by taking the derivative of my answer, okay? So good old power rule, fly and subtract. So when I fly the 4 to the 1/2, I get 2. And then when I drop the power, I get 3, and then the derivative of c is 0, so this does indeed work, okay? So let's formalize what we just did. So think about if I want to derive x to the n, remember that we would fly the n, so we'd multiply by n, and then I would drop the power, right? So I'm going to put that in this order. So multiply and then subtract. Right? Now, if I want to find the antiderivative of x to the n, I would need to do the opposite operations in the opposite order, correct? So let's try. So the opposite of multiply, subtract, again, in the reverse order would be add and divide, right? Okay, so what I'm going to do is bump up my power now. So x to the, what do we think? N plus 1. And now I want to divide by my new power, okay? So I'm going to divide by n plus 1. I'll do it that way. Okay, so that would give me one of the antiderivatives, right? And then I can add constants and get the family of functions, okay? So let's test it out with the one we just did. So let's test it here. So I am going to first bump the power up by 1. So my new power is going to be to the 4th. Now take my new power and divide. Let me give myself more space here. So I'm going to divide by 4, or which is the same as multiplying by a 4th, right? And 2 over 4 reduces to 1/2. Same thing as what we got here. All right, and force a pause on your screen. Will you copy these? And here's where you're going to want to have your little reference sheet handy. All right, let's try this first one. So I've got the integral of 2x minus 2x cubed dx. Remember that this integral symbol with the dx is what we call an indefinite integral. It means find all antiderivatives of the stuff in between, okay? And then once you've completed that command, you need to drop the integral and the dx, okay? All right, so my understood power is 1 here, so I'm just going to go term by term. So I'm going to bump the power up by 1, so I'm going to keep that coefficient of 2. Bump the power up by 1, my new power will be 2. Now divide by my new power. Okay, now minus, so let me keep that 2. All right, my next term, my old power is 3, bump the power up by 1 is 4, and now divide by 4. Okay, and then we always want a plus c at the end, okay? So that's my antiderivative. Let's just clean it up again. 2 divided by 2 is 1, so those go away, and then 2 divided by 4 reduces to 1/2. So that is my answer. Again, sorry, let me move myself. Again, notice that my integral symbol, my dx are gone, okay? Because those are the commands to take the antiderivatives. Once you've taken the antiderivatives, you have completed the command, so those symbols should no longer be in your final answer, okay? Now, how can I check myself? I can always check by deriving my answer, right? So let's try. Derivative of x squared is 2x. Here, when I fly the 4 to the 1/2, I would get 2. Drop the power, my new power is 3, derivative of c is 0, and this is exactly what I started with there, so we did good. Okay, how about integral of cosine x dx? Again, the integral with the dx means find all antiderivatives of cosine of x. In other words, all functions whose derivative is cosine x, okay? So let's see. We know some variant of sine of x plus c, right? So now we just need to decide, is it positive or negative? Well, let's go the other way around. What is the derivative of sine of x? The derivative of sine is cosine, right? So I'm good. I'm done. I've got it. You can take a look at your reference sheet as well. If you look at where the derivative is cosine x, your original function was positive sine, okay? Now, if I want to find the integral of sine x dx, again, this means take the antiderivative of that stuff, right? So again, I know it's some form of cosine of x plus c. I just need to decide, is it positive or negative? Well, what's the derivative of cosine of x? It's negative sine. So I would need to adjust here and put a negative in front, and now it works for me, right? If I take the derivative of my answer, I get back to where I started, okay? All right, what about this secant x tan x? Don't go too crazy. The antiderivative here is just secant x plus c. Again, look at your reference sheet, look at your f prime column, and do you see secant x tan x anywhere there? Yeah, secant x tan x is the derivative of secant x, right? So, so that means that secant x is the antiderivative in this case. I'm forced to pause on your screen. Can you please copy example 2 for me? All right, so here we've got integrals, and then we have 1 over something, okay? This is where I really need you to just be careful, all right? So if I look at this first one, I want to find the integral of 1 over x dx. In other words, what is the antiderivative of 1 over x? Well, look at your reference sheet. Does 1 over x appear anywhere for the f prime column? It does, right? The derivative of ln of x is 1 over x. That means the antiderivative of 1 over x is ln x, okay? A couple things. Always put absolute values around your argument there. That's just because we can't take the log of a negative number, so just kind of to cover our bases there, and then don't forget your plus c, okay? All right, take a look at the second one of example 2. Do you see 1 over 1 plus x squared anywhere in your f prime column of your reference sheet? Yeah, this is the derivative of arctan, right? So this means that the antiderivative of this quotient here is arctan of x. Don't forget your plus c. Okay. All right, now let's look at that last one. Look at your reference sheet. Do you see 1 over x squared anywhere in your f prime column? You shouldn't, okay? So any ideas here? Well, we don't have like an anti-quotient rule or anything yet. How would you derive this thing? Hopefully you would rewrite, right? So let's do the same thing. If I want to anti-derive, why don't I go ahead and rewrite it like so? Is that the antiderivative? Nope, just the same thing rewritten, right? That's why I have my equal signs there with the integral and the dx still, right? Because I've not completed the calculus step. I've not completed the command of finding the antiderivative. Okay, but now we can go ahead and use our anti-power rule, right? So bump the power up by 1. Where would that be? That would be at -1. And then divide by -1, which is just going to give me a -1 coefficient, right? And what am I missing? My plus c, okay? Again, we can always check by deriving what we got. Let's try it. So if I fly the -1 to the -1 coefficient, that gives me positive 1x. Dropping the power gives me a -2, and the derivative of a constant is 0, and that's what we started with here. So kind of the moral of that last one is we don't have an anti-product quotient or chain rule per se. We have ways to deal with products, quotients, and compositions that we will get to soon. But I would like for you, I'm going to force pause on your screen, I'd like for you to just write that sentence as a big reminder to yourself. All right, so if we don't yet have an anti-product quotient chain rule, how do we deal with like products and quotients in particular for now? And that is going to be similar to how we dealt with them before we had a product and quotient rule for derivatives as well, and that was to rewrite, okay? So I'm going to force a pause on your screen, and then we'll do example 3. Okay, so let's take a look here. We've got the integral of x times the cube root of x dx. Again, that integral and the dx means zone in on that stuff and find me the antiderivatives, right? However, I know that I, just like with, since I can't go with the product like derivative times derivative, I certainly can't go antiderivative times antiderivative, right? So we need to get this in a format where we know we can indeed find antiderivatives. So let's do this. Let's go ahead and write this as x times x to the what? 1/3, just rewriting. I still have a product though, so let's go ahead and combine those by adding their exponents. So 1 plus 1/3 is 1 1/3, or 4 over 3, right? Notice I still have the integral and the dx, so I have not dropped those because I haven't done any calculus yet, right? I've not taken the antiderivative. Okay. Now we can go ahead and anti-derive. So I am going to bump the power up by 1. So that's going to give me 7/3 in my exponent now, right? And now I want to divide by 7/3, which is the same as multiplying by 3/7. Yeah, when you've got a fraction, don't do divided by a fraction because it just doesn't look good. Just multiply by the reciprocal instead. And don't forget your plus c, okay? All right, so let's look at this next one. Let's first rewrite this because it's a quotient, right? So I definitely need to rewrite, meaning I still need my integral symbol. And what I'm going to do is I'm just going to go term by term by term and divide by x. So like 4x squared over x would just be 4x. When I subtract the powers here, I would just get plus 5, and then I would get minus 2 over x dx, okay? Again, I've not dropped the integral in the dx because I've not done any calculus yet. I've just done some algebra. Now we're going to do the calculus, so now I can drop the integral. All right, so here's an understood power of 1, right? So my new power is x squared. When I take my coefficient and divide by my new power of 2, I get 2, right? All right, what do you think the antiderivative of 5 is? Don't say 0. It's going to be 5x, right? Because the derivative of 5x is 5. You can think of this as 5x to the 0 if you want to, and do your anti-power rule there. Okay, now I need you to be careful with this last term. Your coefficient is -2, right? So that's going to come with me, my -2. And then I still have this 1 over x, right? But haven't we done that before? What's the antiderivative of 1 over x? Look at your reference sheet. It is ln of, and I'm going to slap on the absolute value of x there, okay? And don't forget your plus c. Okay, you all, that is all I have for this time, and I will see you next time.